to record this for those people who are not here. So we've got a recording, but you guys, so problems, what numbers were those that we did the construction problems on? 11, 12, and 13? 11, 12, and 13. So if you weren't here, couldn't do the construction problems on the board. We went through the rest of 5.3 to make sure you guys know how to do it. That's due on Wednesday. Does everybody understand that? That is due on Wednesday. Okay, today we are going to, I have a little PowerPoint presentation. I'm going to be changing some of the definitions on here because I didn't write this PowerPoint presentation, and I've been teaching geometry for 22 years. Some of these definitions aren't all the way correct. So as we go through this, you'll see me change some of these. But everybody get out your notes. Okay? We're going to go through some definitions of quadrilaterals. Okay? The first definition of quadrilateral, any flat two-dimensional figure with only 4 straight sides. Okay? I'm going to add to that it has to be closed. It has to close exactly one area. Closed means it's going to make an enclosure. Now, by this definition, one of these is not a quadrilateral. Raise your hand when you know which one of these figures is not a quadrilateral. Okay. Faith, which one? That looks like a what?
An hourglass.
The one that looks like an hourglass. You're talking about this one right here, right? Okay, yeah, that one encloses 2 areas. And even though it has 4 straight sides, it's not a quadrilateral. Okay, now one of these, out of the 3 that are left, they're all 3 quadrilaterals, but one of them is a different quadrilateral than what we're used to seeing. Which one is that? Yeah, this one right here, right? That one's a little bit different than we're used to seeing. The reason being is because this angle right here is what we call a concave angle. It points in, caves in to the figure. Do you see that? Kind of caves into the figure. So that's called a concave angle right there. And so it's a convex quadrilateral. Usually the kind that we study in geometry are what we call convex quadrilaterals. These right here are convex quadrilaterals, and those are the kind we're going to study. Now there's some special types of quadrilaterals. Let's go to the next slide right here. A trapezoid. And I don't know who made these definitions, but I don't like how they said a 4-sided figure. Because now we just defined quadrilateral, so can we just use the word quadrilateral for that? Whoops, quadrilateral. So, a quadrilateral with 1 pair of parallel sides. It should say exactly, with exactly 1 pair. Exactly 1 pair of parallel sides. Okay? So, you guys all know what a trapezoid is then? Everybody draw a picture of a trapezoid by that. Notice that these 2 right here have 1 pair of parallel sides. It has that one parallel that one. This one has this one parallel this one. Those are called trapezoids. Do you see trapezoids in real life sometimes? You see them. Sometimes you don't. You don't always think of them as a trapezoid, but they are trapezoids. Like if you look at the front of, like some stands go up in a trapezoid shape. Like I know those, they use them to do, they jump on in weight training class. Aren't they shaped like that? Yeah, the plyometric boxes. Well, some of the plyometric boxes used to be. I don't know if they still are. Are they like that? They have what? A set of 4 of them. Are they trapezoid shapes? Yeah, like that. So that's one place you see that, the ends of them. So that's a trapezoid. Okay, the next one. Right here. Definitions of quadrilaterals. Okay, a parallelogram. Instead of putting a 4-sided figure, what are we going to put? A what? Anybody there? Okay, a quadrilateral with opposite sides parallel and equal in length. Well, yeah, the opposite sides are going to be parallel. The equal in length part, we don't even need, because that's a property of a quadrilateral. You don't need it to define it. If it's a quadrilateral and opposite sides are parallel, that's all you need. So, should put a period right there. A quadrilateral is a quadrilateral with opposite sides parallel. That's called a parallelogram. Some other pictures of parallelograms, sometimes they look like this. But that's parallel to that, and that's parallel to that. Okay? Is a rectangle a parallelogram? Yes, it is. Okay? So that is a parallelogram. Can anybody think of parallelograms in real life that are not rectangles? If you ever see them. A square is a parallelogram. Most parallelograms you see in life are rectangular or square, but there are others. I see them it's usually in designs like wallpaper or floor designs or rug designs or clothing designs. Anybody have some on? We got our plaids on today, right? But they're mostly rectangles, right? So, okay. All right. Okay, so next one. Rectangle, a quadrilateral in which every angle is 90 degrees. Okay? You know what we should put? Forget that, you guys. We should do this. A parallelogram. Because that tells us that opposite sides are parallel. A parallelogram in which every angle is 90 degrees. You don't even need this other part. Those other parts are properties. Opposite sides are parallel and congruent, but the part where it says that they're congruent is a property. That just by nature of being a rectangle, by definition of a rectangle, it has a property that says that the opposite sides are going to be congruent. Okay? Are we writing these down really well? Because you're going to use them to study for your next test. By the way, we're having a test next time you guys come to class. Yeah, it's going to be a mid-module test. I'm going to start giving mid-module tests because it's too long in between when I give you guys an end-of-module test. We are going to do that. And by the way, you guys, about the test, I have not counted a test or a quiz on this term's grades. So any of you who are doing really bad in this class right now, this is an opportunity to really boost your grade. Because this will be worth 60% of your grade. This test will. Cool, huh? This will be worth 60% of your grade. So if you study really hard for this, and you do really well on it, your grade could go way up. Okay? Next one. Here we go. A rhombus. Okay, I'm going to scratch this quadrilateral world out, and I'm going to put a parallelogram with all four sides congruent. Okay, we don't need to write this because that's by definition of being a parallelogram. A parallelogram, a rhombus is a parallelogram with all four sides congruent. Look at this one, you guys. What else? What do you guys usually call this shape? A diamond. So if you want to put that by it, that's what you people usually call a diamond. But the official mathematical name for it is a rhombus. Okay, so the next one. Make sure you guys are drawing pictures by these, by the way. And if you want to, since the definition is all four sides congruent, you can put marks on it like that. All four sides have to be the exact same length. That's called a rhombus. Okay? Next one is a square. And I'm going to scratch out quadrilateral. I'm going to put parallelogram. A parallelogram with all sides congruent and all angles 90 degrees. That's a square. You guys all know what a square is, but that's the definition that we give by it. Now I'm going to draw a tree diagram of how all quadrilaterals relate to one another. And oh, there's one other that they didn't have a definition for, a kite. I'm going to talk about a kite. Does everybody have this written down? Okay. I want to show you guys, first of all, a kite. So write this one down as well. This is another quadrilateral. A kite, by definition, is a quadrilateral with two pairs of adjacent sides that are congruent. Two pairs, so it's a quadrilateral with two pairs of adjacent sides congruent. I like using symbols when you can, okay? All right, so that means the two sides, adjacent means they have to be next to each other. Adjacent means next to each other. So these two sides are next to each other. They connect down here. These two sides, this side and this side connect down at the bottom, and they're congruent. And then right here, these two sides connect to make those two congruent to each other. And that's a kite. You guys all know what a kite is because you guys all flown a kite, right? Go ahead, Brendan. I was like, just sing louder for us. No? All right. Saw Mary Poppins recently? Okay. All right. I like Mary Poppins. All right, everybody write this on here. This is really important to understand how quadrilaterals relate with one another. Okay? This is what they do. Quadrilaterals. There's really three types of quadrilaterals. There is a parallelogram. I mean, three types of special parallelograms. There is a trapezoid. And there is a kite. Okay, those are the three special types. Now, from there, parallelograms, there's two special types of parallelograms. There's actually three. But one of them is a rectangle, and one is a rhombus. And then the third one is a square, because a square is a parallelogram that is both a rectangle and a rhombus. It has four congruent sides and four congruent angles. So there's a little bit of a diagram that you can see. Now, and some quadrilaterals are not special, so they just go into the category of quadrilateral. So you got quadrilaterals. You got three special types: parallelogram, trapezoid, and kite. And rectangle, rhombus, and square are all parallelograms. A square is even more specific. It's both a rectangle and a rhombus. Okay, and so that's what that looks like. What was that? Can it what? And it made a kite. Yeah. Didn't even realize that. He's talking about this if you guys haven't seen that. Made a kite. Okay, any questions there? Okay, so back to the PowerPoint. Okay, I want everybody to go to number 1 through 6 on lesson 5.4. We're going to do, I guess I got to give it to you, right? Okay, you're doing problems 1 through 6. You just got to name all the quadrilaterals is trapezoids, parallelograms, rectangles, rhombus, square, or kite. I want you guys to put these or none of these. List all that apply. So make sure you add kite to that list. So which one's a kite? Number 5. Which one's a square? 4. So if it's a square, what else is it? Rectangle, rhombus, one more, and a parallelogram. Number 4 has 4 names you're going to give it. It's a parallelogram, a rectangle, a rhombus, and a square. Okay, what's number 3? Trapezoid has 1 pair of parallel sides. What's number 2? What? Number 2, it doesn't have anything that's showing parallel lines, but what does it have? It has 4 congruent sides. What do we call a shape that has 4 congruent sides? A rhombus. Okay? What about number, and by the way, if it's a rhombus, what else is it? A parallelogram. Okay, number 1. What's that one? Rectangle and a parallelogram. Okay, we got it? All right. Okay, you guys go write down this definition right here. Postulates and theorems. What is the difference between a postulate and a theorem? What is the difference between a postulate and a theorem? Read those 2 definitions. What is the difference, you guys? Ponder that. What do you think, Faith? What's the difference between a postulate and a theorem? Say that again. I can't hear you. Oh, okay. Read it really quickly, you guys, and see what it is. What's the difference between a postulate and a theorem? Okay, so the difference is postulates have not been proved. Theorems have been proved. Okay? All right. Make a list of what you know about this figure, which was formed by rotating a triangle about the midpoint of one of its sides. Let me show you what I mean by this, you guys. Actually, everybody put your pencil down for a second. I just want you to watch this part. Let's suppose that this is the midpoint. I know it's probably not exactly that. We're just guessing. But if we were to take this bottom triangle and we were to rotate it about this point right here that we've created, that midpoint, 180 degrees, that means halfway around it, where would it end up? Where do you think, Marie? Yeah, it would end up right here, wouldn't it? That's where it would end up, right there. Okay, and what happens when you put 2 of those together like that? What shape does it make? A parallelogram. So it says, make a list of what you know about this figure, which was formed by rotating a triangle about the midpoint of one of its sides. So one of the things you know is that it formed a parallelogram. What's something else? What else do you know about this? And do you know anything that's congruent? Say that again. Okay, everybody write down. Side A, so you'd write it like this. Side AB is congruent to what? Okay, to, not BC. Because we rotated this side right here, we rotated clear around to B, right? It's this side over here, right? Which is A prime C. Side A prime C. It looks like a T, doesn't it? That's supposed to be the segment symbol over the top. A prime C. I should do that a little differently. Should be, this is A prime, so that's like that. A prime C. Okay, what else is congruent? BC is congruent to BC. What else? Huh? Line CA is congruent to what? Okay, line CA is okay. So if you write that one, line AC is congruent to. Got to line these up. What A is with A prime, right? So you got to do that one first. A prime B. Okay, so AC is congruent to A prime B. What else? Any angles that are congruent? Angle B and angle C are the same, okay? Because you have one of these big ones and a small one. Big one and a small one. What else? A and A prime are congruent. Okay, so those are some of the things that you see right there. Okay, would that be enough to prove that those two triangles are congruent? Yeah. Okay. All right, here we go. Next one. This shape is an example of a transformation. That's the one we just did. Okay, we're going to talk about rigid transformations. There are three main types of rigid motion transformations: translation, rotation, and reflection. We know about these already. We've studied them, right? What is another name for translation? What's the easy name for translation? Slide. What's another name for rotation? What is it? Turn. And what is the other name for reflection? Flip. Okay, so everybody knows those? What does it mean by a rigid transformation? Right here, it says the word rigid. Stays flat. Yeah? Stays what else? Did this one, when we rotate it, stay the same shape? Did it stay the same size? Yeah. In other words, it does not dilate. It doesn't get bigger or smaller. It stays exactly the same shape. Okay? It preserves shape and size. Okay, right here, using the Chromebooks. Everybody do this right here. Actually, write this down. We're going to go to HTTP. Everybody write this down. You're going to take this in there. HTTP : www. So HTTP : www.shepardsoftware, SHEPPARD software.com /mathgames /geometry /shapeshoot /translate shapeshoot. And see right here, there's a capital T, a capital S, and a capital S right here in this translate shapeshoot. You have to get those capitalized. .htm. Okay, you're going to click on Start in the middle of the page. You're going to copy the definitions of translation. You don't have to, because we just did. You don't have to copy those down. After you finish writing the definitions, play the game by selecting Start at the bottom. When you finish the game, log off and replace them. I couldn't get the Chromebooks today because another teacher was using them. So we're going to go into this writing lab right next door, and we're going to play this game. So this assignment's due on Friday. Just take all your stuff with you. Put everything away before we go. Take everything with you. Go play that game, and when the bell rings, you can go.